This is Venkat from DataQuest. I will be covering Snowpipe streaming in this session, a real-time data ingestion for the modern data tech stack. What is Snowpipe streaming? It is a service from Snowflake that helps to ingest the data in real or near real time. Snowflake service for continuous low latency loading of streaming data directly into Snowflake, making data available for query and analysis within seconds. The key features includes real-time data availability, direct row ingestion, simplified pipelines, serverless and scalable. Let's elaborate more on each feature. Real-time availability. Ingest data as it arrives, provides live dashboards, can generate real-time analytics such as fraud detection. Direct row ingestion writes rows directly to tables, bypassing the intermediate cloud storage staging. Simplified pipelines. Ideal for application events, IoT sensors, CDC streams, and message queues like Kafka. It is serverless and scalable. Auto scales compute resources. Billing optimized for high volume streaming feeds. Snowpipe streaming is a serverless compute engine that would help to ingest the data in real or near real time. Two kinds of implementations currently available from Snowflake. One is high performance architecture, it is recommended to use. The second one is classic architecture, it is generally available and it is an old pattern. Let us go over each feature within high performance architecture. So HPA, which is high performance architecture, is the next generation implementation. There are several language SDKs available such as Java, Python, and REST API. This new architecture uses pipe object for data flow plus lightweight transformations in flight. There is a changing in the pricing model. It is throughput based pricing, credits per uncompressed GB. REST API for direct ingestion, for example, IoT edge deployments. Server-side schema validation. It also supports geography and geometry types. Let's take a look at classic architecture, which was already in place and it is a proven implementation since the beginning of Snowpipe streaming. It was only Java SDK available. There was only Snowflake ingest SDK with Java. There was no pipe object required for classic architecture. Channels open directly against target tables. Pricing based on serverless compute plus active connections. Geography and geometry were not supported. It is suitable for existing pipelines. Snowpipe streaming versus Snowpipe. Let's dig deeper into Snowpipe streaming versus Snowpipe, which is also used for ingestion pattern in Snowflake. On the left side, you would see category. We have data form, latency, ordering, pipe object, use case, SDK, load history. By category, let's compare Snowpipe streaming with Snowpipe. Data form, Snowpipe streaming accepts rows the streaming records, whereas Snowpipe accepts files in the blob storage. The latency is seconds, which is near real time in Snowpipe streaming. Snowpipe, typically in batch intervals, you would expect in minutes. Ordered per channel in Snowpipe streaming. Ordering is not guaranteed in Snowpipe. Pipe object is required for Snowpipe streaming, primarily for high performance architecture, but not for the classic architecture. Snowpipe always requires pipe object. Typical uses of Snowpipe streaming are Kafka, IoT, CDC, app events, which are real time. If files needs to be ingested from cloud storage to Snowflake, Snowpipe is the right choice. Java, Python SDKs plus REST API is required or is available in high performance Snowpipe streaming architecture, whereas it was Java only in classic architecture. There is no SDK required in Snowpipe. Loading the historical data, Snowpipe streaming file migration history is available, part of Snowpipe streaming. Copy underscore history is available in Snowpipe. Channels, the core abstraction to read the data from source, to ingest the data into target. A channel is a logical named streaming connection to Snowflake for loading data into a table in an ordered manner. For example, let's say if you're reading from Java SDK, it uses the channel. Through channel, it moves the data into Snowflake table. It establishes long-lived connections. Channels should be reused across restarts. Offset tokens are retained. Auto flush every 1 second. Data is automatically flushed. Channels don't need explicit closing. Multiple channels per table. One client can open channels to multiple tables, not across accounts. Drop channel request API permanently removes channels plus metadata, data flushed before drop. In a summary, channels are the core abstraction to read from an SDK to write into Snowflake, logical streaming connection. Offset tokens, exactly once delivery. Offset token, both architectures, user defined identifier, you assign the value. Snowflake stores it but does not use it internally for dedupe. External systems, for example Kafka, read it to track ingestion progress. Prevents duplicate data on stream replay. Continuation token is only for high performance architecture. It is managed by Snowflake, returned after each append rows call. Must be bounced back in the next request to ensure correct ordering is maintained. Prevents duplicate or missing data during SDK retries. Critical for maintaining a single continuous streaming session. Let us go over Kafka example. Considering a channel name TP1, which is in a topic, P1 is the partition. Snowflake reads an offset 10, that is 10th record in the partition. On crash, it reopens the channel and it gets the latest committed offset token, and Snowflake returns 20 to Kafka and resume reading from offset 21 with no duplicates. So this whole architecture ensures that it is read only once and no duplicate data is produced. That's the power of Snowflake Snowpipe streaming. Key constraints and access privileges. Some of the constraints that we can go over here is insert only. API currently supports insert operations only. Updates and deletes require separate pipelines. 30-day inactivity. Inactive channels and their offset tokens are auto-deleted after 30 days. Classic architecture supports Java-only SDKs. High performance adds Python and REST API. No cross-account channels. Plain SDK cannot open channels across Snowflake accounts. Required privileges. The table ownership are insert plus evolve schema. Table requires ownership or insert plus evolve schema privileges. Database should have usage role for the service account that it is loading. Schema should have usage privilege. Pipe object should have operate for high performance only privilege. The best practice for CDC, IoT, and Kafka workflows requiring sub-second latency with exactly once delivery, the high-performance architecture with pipe objects and throughput-based pricing is the recommended choice for new projects. So, ready to stream? Bring your data to Snowflake in seconds, not minutes. Use Snowflake's high-performance architecture. Evaluate high-performance architecture for new streaming projects. Integrate using Snowpipe Streaming SDK with existing Kafka or CDC pipelines. Explore pipe objects for lightweight transformations at ingest time. So this is all about Snowpipe streaming for beginners.